Hey everyone, welcome back to your Career in IT channel. Today we are diving deep into an exciting data science project. As you can see the title on the screen, California housing price prediction using machine learning. So we will take you through the entire process. The first step, data visualization, pre-processing, model training, evaluation, and deployment as a live API. So stick around and let's bring this project to life. So we are working with the famous California housing dataset. This dataset includes information such as average income, house age, latitude, and longitude. So which we will use to predict housing prices. So sounds exciting, right? So let's get started. First, we import our essential libraries for data handling, visualization, and machine learning. And after this, we load the California housing dataset and convert it into a pandas data frame, making it easier to explore and manipulate. So, first, you will need to open the Jupyter notebook, create a new file, and select your desired environment. Now, import pandas as PD. Now, import numpy as np. Now after this import matplotlib dot pyplot as plt. Now after this import cbone as sns, and the last one is from sklearn dot datasets import fetch underscore california underscore housing. Now load the dataset. So california equal to fetch california. Now df equal to pd dot data frame. Now pass the argument to the first one is california dot data comma columns equal to california dot feature name underscore feature name, which is names. Okay, so the next one is the our target column is price equal to california dot target. Now after this quick overview of the data. So first print df dot head, which shows only the top 5 rows. The next one is print df dot info. Okay, the last one is print df dot describe. Now run the code. Okay, so here you can see only the top 5 rows, which indexing start from 0 to 4. Now info is this, how many columns and its types, uh, and the last one is describe. So it shows a mean, median, a standard deviation, minimum, maximum, 25%, 50%, and 75% of each column. So df.info summarize the structure, and .describe provides statistical insights. So this help us understand the features and detect any potential issues. Okay, now the next one is visualizing the correlation matrix. Okay, so for this we use plt dot figure. Now fix size, which is equal to 10 and 8. Okay, now after this sns heat map df dot correlation. Now comma after this annotation equal to true. So cmap equal to, which is color, cool, warm, fmt equal to point 2f, and the last one is plt dot show. And now run the code. So here you can see the correlation matrix. So the correlation matrix shows the relationship between features. Darker red or blue indicates a strong positive or strong negative, as you can see. In the blue, strong negative, and in the red, strong positive. So for instance, median income, this one, median income might strongly correlate with housing prices. Okay, now our next step is data pre-processing. Okay, so for this, again we import our libraries sklearn dot model selection, import train test split, again from sklearn dot pre-processing, import standard scaler. Okay, now first check for missing values. So print df dot is null dot sum. After this key splitting the data for, so x equal to df dot drop price, x is equal to 1, and y equal to df price. Okay, now after this splitting the data for training and testing. So for this x underscore train, x underscore test, y underscore train, y underscore test equal to train test split. So here we use x, y. Now the test size is 20%. So here we use 0.2, and the random state equal to 42. Now after this standardization. So here we use scalar equal to standard scalar. Now after this x underscore train scaled, so scalar dot fit underscore transform, and here we use x underscore train. Now same is the case for x underscore test, scalar dot transform, where is transform, and underscore x underscore test. So here we handle missing values and split our data into training and testing sets. We also scale the features for better model performance using standard scaler to normalize the data. Now run the code. Okay, so there is no null values. Now after this we need to train the model. So training the model. So again we use to import some libraries from sk learn dot ensemble, import random forest regressor. Okay, now after this from sk learn dot matrix, import mean, absolute error, mean, squared error, and the last one is r2 error score. Okay, now after this initialize and train the model. So here we use rf underscore model equal to random forest regressor argument n underscore estimators equal to 100 and random state equal to 42. So rf underscore model dot fit x underscore train scaled comma y underscore train. Now after this prediction, so y underscore rf underscore model dot predict x underscore test scaled. Now evaluate the model. So here we use mean absolute error underscore absolute error. So y underscore test and y underscore predict. Now after this mean squared error MSE equal to mean underscore squared error y underscore test and y underscore predict. Okay, so after this RMSE root mean squared error. So here we use np dot square root MSE. Now after this R2 equal to R2 underscore score y underscore test comma y underscore predict. Now print these values f. So mean absolute error MAE and the next one is MSE mean squared error MSE. Okay, now after this RMSE root mean squared error as given you ARED RMSE. Okay, now after this R squared error. So here we use a R2. So here we use a random forest regressor to train our model. After training, we evaluate it using metrics like mean absolute error, mean squared error, root mean squared error, and R square. Now run the code and let's see what we will get. Okay, so here you can see the values of the mean absolute error, mean squared error, root mean squared error, and R squared error. So MAE of 0.327 means the average error in prediction is about $32,700, and mean squared error and root mean squared error indicates how close the predicted values are to actual values, and the R square of 0.805 shows that our model explains about 80.5% of the variance in housing prices. Now after this we need to save the model. So how we can do this again, import joblib. Now save the train model and scalar. So joblib dot dump rf underscore model. Now set the path. So my path is or I'm going to copy this. So the model name is a random forest model with extension .pkl. Now same is the case for scalar. So the path is same for the scalar as well. So scalar.pkl. So we save the train model and scalar using joblib so we can reuse them without retaining. So this is essential for deployment. So run the code. Okay, now here you can see both files are stored in the specific folder which is mentioned here. Now our next step is deploying as an API. So for this I am creating a new file with the extension .py. So control N, California price prediction. So here I am using project.py, save. Now import some libraries from Flask, import Flask, request and JSONify. Now after this import numpy as np. Now the last one is import joblib. So get the model equal to joblib dot load, copy the path of the model, paste it. Okay, now after this same is the case for scalar. So equal to joblib dot load, the file name is scalar dot pkl. Now after this app equal to flask name. Now after this underscore app dot route predict method equal to post. Methods app dot route. Now define the function which is predict colon. Now here we use data equal to request dot get underscore json. Now after this input features equal to np dot array. Now data features features dot reshape 1 minus 1. Now after this scaled features equal to scalar dot transform input underscore features. Now after this prediction equal to model dot predict scaled underscore features. Okay, now after this return JSONify, use the curly brackets. Now predicted underscore price colon prediction 0. Okay, now after this if underscore name again underscore equal to main. So app dot run debug equal to true, port equal to 501. Now save. Okay, so it's now save and run. Okay, so the server is started. So using Flask we build an API for our model. So it accepts input features via post request, scale them and predicts housing prices. So finally it returns the results as a JSON response. Now our last step is testing an API. So for this also create a new file, control N, save as test underscore predict dot py and save. Now import the library which is requests. Now put some data for testing. So features Now here we put some values like 8.3252. You can test the model on different values as well. 41.0. You can also ask the values from the user using Tkinter library. 4126, 1.023810, 322.0, so 2.637.88 minus 122.23. Okay, so response equal to requests dot post. So for here HTTP, I'm copying this and copy here predict, now comma JSON equal to data. Now print response dot JSON. Response P-O-N-S-E. P-O-N-S-E. Okay. Now save the file and terminal test dot predict copy file path. Okay, now run the file Python. Okay, enter. Okay, so we get an error. 1, 2, 3, 4, 5, 6, 7, 8. Now open the new window. Project.py test underscore predict.py. Also double check the file name test underscore predict.py and run. List object has no attribute reshape. Okay, so the error is here. SHAPE. Now again reshape. Okay, so close the terminals. Terminate. Now again run the code. Project. Okay, open the new window of terminal. So here use test underscore predict dot py. Now run. Okay, so still error is reshape input feature. So the error is here. Same the error is okay. So the error is here. This bracket should be here. Now save. Now okay, so it's working fine. So here you can see the predicted price is 4.232, so which is $42,000. So we test the API using requests in Python. Here where we input features and the API predicts the housing price. So this demonstrates the power of machine learning in production. So that's a wrap for today. From data processing to model deployment, we have covered everything you need to build an end-to-end data science project. If you enjoyed this video, don't forget to like, share and subscribe to my channel. So let us know in the comments what you would like to learn next.